Maybe. Hi, welcome to Live Coding with me, Rachel. I'm just going to double check that everything is going correctly. That looks good. Fantastic. And that also looks good. Great. Okay. Hello. Welcome. Today, we are going to be working on, first we're going to work on not having peaky audio. Today we're going to be working on our dialect classifier. So we've been working on a project for about 6 months now, and basically we are re-implementing the New York Times dialect quiz. So the New York Times dialect quiz is this quiz. There's 25 questions. It's multiple choice. You answer and you go through, and then it says where in the United States people speak most like you. So we're doing the same thing, actually with the same underlying data, courtesy of BirdBox, to as, I guess, with wrong preposition, a conversational AI. So you will be asked a bunch of questions in order and answer the questions, and at the end, all of that information will be taken, run through a classifier, and you'll get back, hey, this is where in the US we think people sound most like you. That is the general idea. And what we're working on right now is the classifier. So if you've been following along for a while, you know, we've actually already built a classifier. So the whole assistant works, like all of the things that it's supposed to do, it do. However, the output we were getting from the original classifier we built was absolute nonsense. It did not, didn't make sense. I think we had like a 0.5% accuracy rate based on city-state combination, so not the best classifier. And we're going to be doing a different classifier that hopefully works better. The other thing that will hopefully make our assistant work better is we had the first data set. It didn't have a data dictionary, and the data was just numbers, right? It was just numeric, but the answers are text. So I sort of guessed how the encoding scheme went, and I think I guessed wrong. So we got a new data set with a new data dictionary, and that one we are using, and I'm pretty sure it's right. We've done a lot of hand validation. I feel pretty good about it. A little sip of water. It's got electrolytes on it. That's why it's pink. Just like a baby chick that shows up in the mail. You give them electrolytes once they show up in the mail. That's the whole thing there. Anyway, the big difference between the classifier that we have here and the one that we had previously is the data that we got the first time had zip code, city, and state. This data has latitude and longitude. So I think what we're going to do is we're going to build a classifier that finds the k nearest neighbors from, something has just occurred to me vis-a-vis data privacy. Well, we'll cross that bridge when we come to it. So I don't have permission to share the data. If you click on the link in the YouTube description, you will get the assistant code, but you will not get this code. And you won't see this data just because I don't have permission to share it. I'll upload the modeling code once it's done, but you won't be able to run it because you won't have access to the data. But, squeaky chair, I do need to oil it. Yeah, let's give it a shot and then figure out how we can do this without actually having the data exposed. So what I'm thinking is we have a bunch of thinking in here. So our approach is going to be, and hat tip to Amir, I'm assuming, Kelleg, who suggested a variation of this, and I sort of ran with it. We're going to do a k-nearest neighbors classifier on the non-geographic features. So we've done one hot encoding. For every column, we have, for a specific question, the specific answer that user gave, sorry, for a specific question, one of the possible answers, it's a 0 if the user did not say that, it's a 1 if the user did say that. So question 14, we are not using all the questions in the survey. Question 14 says, do you say lawyer such that the first syllable rhymes with boy or law, or either or other? You can see the majority of people here are saying boy, and no one's saying law, no one's saying either, but this one person is saying other. I don't know how you'd say lawyer without writing it with either boy or law. So the other option would be lawyer, which is a little bit more southern. So we have one hot encoded data, which means that we can use numeric options. Also, k-nearest neighbors are a distance-based measurement, which is why we're doing one hot encoding. So the farthest apart two options can be is 1. And if we'd done, you see there's 4 answers here, and we turned it into something between 0 and 3, so 0, 1, 2, 3, we would end up with questions that have more answers being farther apart from each other in this spatial model. And what we're doing instead is we're having a very high dimensional model where every dimension is just from 0 to 1, if that makes sense. Feel free to ask in the chat if you have questions. So once we've done the k-nearest neighbors, we will, so thinking through this, what the classification is going to look like, let me give me a little markdown cell here. Also, I don't know if you can tell, I had a really strong coffee this morning and I feel great. So we're going to be talking pretty fast. Can you please increase the volume? Yeah, for sure. That should be louder. Let me know if that works for you. I can also move my mic. Sorry, this is not going to sound good. Slightly closer. Okay. So, the classification process. So we're going to run classifier on not Is this a markdown cell or is this a code cell? Okay, yeah, that was a code cell. Sorry, I'm not 100% down with the notation they use in the VS Code thing. Oh, hey, Anarchy. Well, it's been a while. Good to see you. And that's good for the volume. Fantastic. I'm gonna lean away from the mic to drink. I know there's lots of people that do not like drinking sounds, but I have to hydrate or my voice will go straight to heck. It'll be awful. Okay, so we're gonna run the classifier on the non-locational features. And then we're gonna get the, I don't know what. Five nearest? 3 nearest? I think 5 nearest makes sense. So something, it's almost more of a regression model, right? Because what we have is latitude and longitude. But no, it doesn't matter because we're not looking at that for the classifier. The classifier just cares about, so what's the class gonna be again? One sec, let's look up k-nearest neighbors in SciPy, or scikit-learn, probably not SciPy. Sorry. I think something's blooming that I'm allergic to. All right, KNN, Python. A lot of tutorials. All right, here's the scikit-learn implementation. So let's take a look at that. Functionality for unsupervised and supervised, unsupervised nearest neighbors, blah, 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 blah. Clustering, regression. Can we do k-nearest neighbors regression? So the reason that I'm thinking about regression is because latitude and longitude are values, right? And not like city and state. Although what we could do once we have the 5 nearest is do with just those 5 reverse geocoding, which is where you take the latitude and longitude and get a place name out, and from those do a majority vote. The likelihood that we're going to get 5 places that are nowhere near each other is real high, though. Or like that don't share names. We could do it at state level. There's 50 states. That's pretty informative. None of them are huge. I say that as like an American. Most of them are like bigger than Germany. They're pretty big in terms of geographical areas. All right, so I'm just gonna write down my thinking here. So take top 5, reverse geocode top 5, and take majority vote. Let's talk about some of my options here. What can I do with this majority vote? I can do state level. I could do zip code. I could do, actually, let's go back up. So here is the information that we get. I cannot do zip code from the reverse geocoding using the reverse geocode library. This is very different from the reverse geocode library, which does not support Python 3, as I discovered a couple live streams ago. And the information that we get back from that is the city, the state, and the county. Now, for those of you who aren't familiar, in the United States, with the exception of Louisiana, I believe, well, also, okay, Virginia is also weird. So counties are like smaller subdivisions of states. In Louisiana, they have parishes instead of counties, but I imagine that's going to be mapped to the same field. And then, well, you know what? This is discoverable. And the weird thing about Virginia that I don't know is unique to Virginia, but yeah, no, I see how that could be, is that cities are actually independent of their matrix counties. So cities have completely separate governance from their, cities have completely different governance from the counties that they are located within. Whereas, for example, Seattle City Council is part of the King County governing body, I guess. What was I looking up? So I just want, let's see, New Orleans lat long. So I just want to get a place that I know is going to be in, basically in Louisiana, just to see if they give you parish information or county, or if that field is just blank, because I don't want to classify on a field that only exists in some of the points. Hopefully y'all are picking up what I'm putting down here. So the latitude is 29.951065, and then the longitude is negative 90.071533. All right. Okay. So we do get parishes out from Louisiana. Okay. So I think we can get by using counties. I'm just gonna look up something real quick. Lat long. Richmond, Virginia. So again, in Virginia, cities are not part of their matrix counties, so I just want to get information about what we get when there may not be a county. Like, do we get counties back? Rachel, it seems like you wouldn't be able, I don't know why I did just copy paste in the first place. Rachel, it seems like this would be difficult to do if you did not have a lot of specialized knowledge about the United States geography and governance. Okay, excellent. Fantastic. Okay, so you can see here that it's the city of Richmond instead of like one of the counties around it, like Chesterfield. Yeah. Okay, so I think we can use this admin2 field to classify. And of course it's going to be different for different states, but yeah, I'm happy with that. So maybe we could do admin1, which seems to be the state, or admin2, which seems to be the I don't know, what would incorporate incorporated cities, parishes, and counties, but whatever that particular degree of distinction is, that's the one. So state would be bigger and probably a little bit easier, and admin 2 would be a little bit more informative. There's going to be more of them, so probably harder to get accurate. So state level, that's field admin 1 that we return from the geocoding, and then zip code, no, not zip code. So incorporated city / parish / county. I believe actually this was admin 1 and this was admin 2. Let's do it correctly. Okay. So yeah, I think that's what we'll do. Yeah. Because if like I took a dialect quiz and it's like, you sound like you're from the state of New Hampshire, I'd say this is a wrong quiz. This is not very good at identifying me. But I think I'd be like okay with state level results. So V9 says, looks like the get link is wrong. So that should be for the, oh, so it is. I see it has been truncated. Yeah, I'll post the actual link up here. GitHub.com. So I'm pretty happy with this plan of attack, and we'll see how it, I don't know, I shouldn't talk about it, attacking things, I'm just trying stuff. I'm pretty happy with this attempt outline. I don't think that's better necessarily. Enrique says, here's the correct GitHub link. Did you build reverse geocode finally or get it from some library? So I am using it from a library. The library is the reverse geocode with an R on the end library, this one. And the reason that I picked this is A, it supports Python 3, because we don't use Python 2 around here, because we have the option not to. And B, because it does it on device, so I don't have to worry about setting up an API for like Google Maps and handling credentials and the admin stuff, blah, 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 blah. I'm too lazy, too lazy to do that. So I'm just not going to. So yeah, I'm pretty happy with our approach so far. So what we're gonna do is non-lexical features, top 5, reverse geocode just the top 5. The reason we don't want to reverse geocode everything ahead of time is because it takes like half a second per instance, and we have about 47,000 rows in our data set, so that's a lot. That's a lot to do, and I don't want to. I do want to select out some it's not like fireworks. I do want to select out some testing data, however, from our data frame. So I'm going to do a little test train split for validation. I am expecting that we're going to have pretty low accuracy overall, where accuracy is defined as having precisely the correct, not state, but like county level. I am okay with that. So I would expect the accuracy for the state to be much higher than the accuracy for the county, to be much higher than the accuracy for the exact city, just because there are relatively few linguistic features that are discriminative of specific cities, and they're not necessarily going to be asked about in this particular quiz. So the questions that I've picked for this quiz are broadly discriminative across dialect regions in the United States, but not necessarily at the city level. So like if I wanted to learn if someone was from, I don't know, Pittsburgh maybe, I might ask them about their pronunciation of water, or try to like elicit the word John. I think that's a Pittsburgh thing. If I want to know if somebody was from Seattle, I might check into their prevelar low back merger, so bag, bag. Those are both said bag here in Seattle. So there are features that are city level. Well, that one's sort of broader Pacific Northwest. That's not just Seattle. But I didn't include those. So I don't expect that we're going to have good resolution at the level of specific city, but we might do okay. I think we're going to have much better resolution at the level of state. So, which is all to say, I'm okay with low accuracy as long as we're sort of in the ballpark. All right. Let's build this classifier. Did I have the k-nearest neighbors in one of these windows over here? I have a bunch of windows just like stacked on top of each other, which is not the best way to manage websites. All right. K-nearest neighbors, learning based on k-nearest neighbors of each query point where k is an integer values, blah, blah, blah. Learning based on a number of neighbors within a fixed R of each training point where R is a floating point value specified by the user. I don't think this is going to work with our extremely high dimensional data. I think you could do it. I think it would just be real expensive in terms of like time complexity. K neighbors is most commonly used, not uniformly sampled. I don't think we have necessarily uniform sampling just because people don't live uniformly across the US, like everybody a mile away from everybody else, and there's just like a bunch of people in the middle of nowhere in Montana. That's not how humans work. But let's give this a shot. Okay, so the first thing I want to do is actually do my test train split. And then fit classifier. And I'm actually just going to look up some example code for the test train split. Scikit-learn test train split. I know you do it using like multiple assignment and the model cross validation. That's the one. There we go. And I don't remember if I've imported scikit-learn. I guess we'll find out, huh? And then what do we call the encoded data is what we called the encoded data. That was a good variable name that I picked. Encoded. And yet it does not exist, probably because I've not run this cell. Let me double check. Nothing's changed. Nothing's changed. Fantastic. Now we should be able to autocomplete. There we go. Sure did not import scikit-learn. And I'm going to put that up here with pandas because I'm sure that I'm going to need this. Is that the correct import? It is. Okay. So the error we're getting is that this thing that I'm looking at in the docs literally right now doesn't exist. Which makes me think that I have messed up the import and that sklearn is the thing that it's usually aliased as. Blah, 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 blah. So it's import sklearn, sklearn.crossvalidation. Maybe they changed the name and I'm looking at an old version of the docs, perhaps? Sure don't. All right. Sklearn cross-validation, that is what I want to do very specifically. All right, looks like I'm not the first person to run into this. Oh, it's been deprecated. Oh, okay, good to know. When did that happen? Okay, last year. Okay, I feel much less bad about this. All right, so test train split has actually been moved. Good to know. You learn something every day. they should probably update the docs. I realize it's an open source project. It could be me that updates the docs, but I'm not going to do it right now. Let's give that a shot. All right, so now we should be able to just use test train split. Nice and easy. And then I believe that I can just do multiple assignment and do test train. Can I do shape test? Test.shape. And then train.shape. I think I did these backwards. I think it's supposed to be train test. 11,000. 355,000. Yeah, no, I definitely did that backwards. All right. And I actually don't want that much data in my training, so I'm just going to real quickly check. Get rid of that. Oh, and I see the years correct information. Thank you. Sorry, there's a bit of a delay. Which hopefully, so I've increased the delay a tiny bit actually, so that I stop hopefully getting that thing where the recording splits in the middle and then there's a bunch of really short videos. And I've tried to go through and I'm gonna change the test time. Anyway, I've tried to go through and change the I think 10% should be fine. What have I tried to go through and change? Mush all the videos together, and the big problem with that is I have no way of keeping the chat, and I don't want to keep the chat because y'all have really good advice, and I don't want to delete it. So, yeah. Oh yeah, and everyone's saying, Rachel, it's train and then test. Yes, thank you. I appreciate your assistance. And that's a much more reasonable size. 4,000 is still like a fair number of points. We could actually honestly even go smaller. Because again, I don't think we're going to have really great accuracy here, and I am okay with that. All right, so let's fit this classifier. Let's pull the docs back up. I've been burned before though, so I'm got my eyes on you now. Scikit-learn docs. All right. So we do have to import this because we did not import all of scikit-learn. We imported, well, we did, but when we rerun the notebook, it will disappear. So, and I'm pretty sure that we are going to end up using k-nearest neighbors. So, I'm okay with that. And I'm just going to import this. I'll just call it sklearn neighbors. It should be fine. I'm not importing all of sklearn because we don't really need it. All right, k-neighbor, nope. Classifier, there we go. And then I think we want number of neighbors to be, what did I say here? Tick tough 5. All right, let's do 5. And then weights, don't mind, don't care, don't care. Regarding nearest neighbors algorithm, we found that 2 neighbors k1 and k, have identical distances but different labels. The results will depend on the ordering of the training data. Okay, we're not using an even number of neighbors, so I'm not super worried about that. Okay, so first we define it and then we fit it. I think we actually want a regressor. So, the thing that I'm thinking about here is, come back up here. So you can see that it takes in the X, which is the target usually, and then Y, which is the actually, I'm not sure. Anyway, one of these is the label, and one of these is the data for assigning the label. And we don't have a label. What we have is latitude and longitude, but the thing about latitude and longitude is that's 2 things. And not one thing, as it turns out. Those are two separate things. And what I wanted to do was find the nearest. So I want the points. I want the points themselves, and after that, I will handle the rest of it. So I don't actually need a classifier. I need like a finder. Let's see what else is in here. I don't think we want to build a classifier, actually. I think this is going to have a problem. Let's see. Nearest neighbors. All right, let's look at what that has. Can I do? Does this work in Python? Probably not, huh? It might. It does work. Okay, fantastic. Number of neighbors 5, radius blah 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 blah. Okay. Unsupervised learning for implementing neighbor searches. Number of neighbors, radius algorithm, leaf metric, p metric, and jobs. Nearest neighbors 204 neighbors.fit sample. Let's make sure you're on silent now. So it's looking for the 2 nearest neighbors for 0.4. Here says you need a distance measure. Yeah, I'm treating it as distance. So what we have is a really wide one-hot encoded vector. I wonder if there's an easier way that we could do this. Maybe finding the most overlap? Panda's most similar row. Two data frames, different. So let's see this. Mohammed says, what are you trying to classify? So here's the thing. So location, broadly. The information I have on location is latitude and longitude. I've not reverse geocoded it to something like state, just because it takes a really long time. And I might have to bite the bullet and just have it run for a while. I don't think there's a way to parallelize it, unfortunately. And we have 47,000 training examples. And so the problem with using a nearest method is, like a table lookup, is that I need to include the data in the, like the data is the classifier, right? I might just need to bite the bullet and just go through and reverse geocode everything. The problem is that's going to take a really long time, like a really long time, like 8 days. Because the reverse geocoder I have is not that big. Maybe it's worth just like paying for. Let's see. I know I'm sort of like drifting from my original intention, but the more I think about K-nearest neighbors, the less sense it makes, because K-nearest neighbors is label based and we just don't have the labels. Also, I'm going to need to, if I try to get around it by just finding the rows with the most overlap, I'm going to need to include all the rows, or at least a representative sample of the rows in the finished assistant, in order to look up every time somebody finishes the quiz what their answer should be. And because I don't have permission to share the raw data, I don't want to do that because I'm open sourcing the assistant itself. So yeah. So let's just try it. Based on data frame 1, what is the most similar row in data frame 2? Minimum distance. Array.min. All right, so I'm just going to try this minimum distance approach and just see if it works. Because I'm interested to know that. So let's look at just like the first one in test. Stupid. All right. Sorry, I always forget how to get rows. Pandas get 1 row. Pandas get 1 row. Bilal says, from SciPy, spatial import distance, distance.Euclidean, A, and then I'm assuming that's a slice to the side. It's deciding that it's an emoji. And instead of correctly parsing it as not an emoji, but Python syntax. That's frustrating. Pandas get 1 row. That's still all I need to know. I've clicked on this link a lot of times. All right, so we can just do like so. No. Oh, is it because of, row with index 1 and 2, row with index 3. This website is lying to me. And then I will leave row and then everybody. Is that gonna work? There we go. Jiminy cricket. Okay, so here we have a single row. I don't know why that was so hard. Frustrating. Yer says, when you use ilock, remember to use brackets instead of parentheses. Why not just use brackets for indexing in? I know there's probably a good reason. It's just frustrating to me because pandas is basically R, except it's not in frustrating ways. Alright, so here we have a single, let's just call this test case. And I want to see if I can get something meaningful out for the nearest row. And again, I don't think this is going to be the approach we're going to take for the final and Bilal says, let's add that here. I don't think this is the approach we're going to take for the final assistant. I just want to see if it can work in theory. This is just me noodling around. So from scipy.spatial, that's the one. Import distance. All right, and then. Paul's like, I didn't write an emoji. It's just being translated into emojis. I feel that. Not that emojis are in a language that you can translate into. Vivek. Offline. Beans. Okay, so sorry about that, and we're just gonna have stream resumed. Okay, hopefully this means it's gonna be in the same gosh darn file instead of a separate one. Yes, okay, great, fantastic. This has been my constant struggle for the past couple months. All right, so spatial distance. Subtract df and then calculate the norm for each row. Small slides. Oh! This is a much dumber way, and I love dumb ways of doing things. So what they're doing here is that they've got, they're subtracting data frame 1 from data frame 2, and then they're just finding the row, the one with the smallest difference. So let's try that. I don't think it's going to work, but it might. All right, so you got test case, right? And then train, all right? And then, which one was DF2? It was test case. Oh, I think I need to, let's see this. So train.values, okay, great. And then test.values, test case.values is an array. All right. df2, but we actually want the training data where it's closest. All right, let's just give this a shot. Something's wrong. Length of class to value is bigger than the index implies. All right. Maybe this is just a dumb. Maybe we'll just use the built-in cosine distance one. I think that's probably a better option. All right. Foop. Have I imported it? I have not. Is that gonna work? All right. And then we can just check out the cosine distance. All right. So cdist. And then we're going to check from the test case, just the single one, and then all of the training data, which is much bigger. And then what's the default? Metric Euclidean? Yeah, I'm fine with that. All right. So let's call this distance. C distance, I think that makes sense. And then we're going to, in the training data, find where the C distance is the minimum C distance. Nope. C distance dot minimum. I am, by the way, working off of this Stack Overflow. And we'll see how it goes. I'm scared. Oh, that's right. It's an evaluation, not an assignment. There we go. Name training is not defined. Is that because I called it train? Sure is. All right. XA must be a two-dimensional array. All right. So data frame 1 is the short one. So we should actually do train. I got these backwards. Training. All right. Nope, still doesn't work. Okay, XB must be a two-dimensional array. Which one is XB? Distance, train, test case. Maybe it needs to be the values of each, so that it's an array and not a. XB must be a two-dimensional. Oh, you know what? I bet test case.values is one-dimensional. Nope, I just wanted to run that one. Yeah, that's one-dimensional. All right, so that's the problem. And we can just double check that that's the case. Yep, that's one-dimensional. Okay. So Mohammed says maybe because you're giving data frames. Oh, again, the chat's a little bit behind me. I'm not ignoring you. Yeah, it seems like turning them into arrays doesn't help, though. It's the problem. Because value should extract an array of just the values from the data frame. All right. Got two suggestions for reshape -1, 1. So this sort of like rotates it, I guess. All right, let's give that a shot. Or Ryan says, hey Ryan, to none. I'm gonna try the reshape one because 2 people mentioned it, and paste. Why not paste? I don't know if this is rotating. Paste. Consistently on this stream, the thing I struggle with more than any other thing is copying and pasting, and I don't know why. There we go. All right. Error. Same number of columns. Okay, so I think that's transposing it, and it doesn't like the transpose. So I am going to use Ryan's hack, and let's see if that works. Oh, you know what? I think it's just my... keyboard. Every so often I just need to restart it so that it keeps working good. What if you typed? Am I out of batteries? That would be inopportune. Also, it's a little wireless keyboard. Are you on? Are you working? Okay, fantastic. Woo. All right, and then everything. None. All right. Same number of columns, i.e. feature dimension. How many columns do you have? You got 175, right? Mohammed says, no, you have to do it for the 2 inputs. Oh, I see what you mean. So transpose both of them. Gotcha. Now I'm picking up what you're putting down. You can't edit the error message. All right, so, and then it was reshape. That makes sense. -1, and then as long as we do the same thing to both of them, they should have pretty much the same size. And I think now is a good time to actually officially bring you down to the second side. I don't know why you didn't indent. That makes me worried. Same number of columns, i.e. feature dimensions. How big are you? 175, all right. Row, column, so that works. How big are you? Right, yeah, that'd do it. Okay, so we've concatenated, shoot. Okay, so we've concatenated everything, so suddenly it's very wide, so that's not gonna work. Is this the best use of my time right now? Folks are helping out. Dimensions must be N2, I think. I'm just depressed because I can't code like y'all, Jimmy says. Oh, don't worry. Used to be none of us could code. Ryan says, you probably want a row for every sample and multiple columns for as many dimensions as you have. Reshape is probably not what you want because it's locking it to a single sample. Yeah. Looks like do not convert the train. It's already multi-dimensional. I believe if we didn't convert the train, we ended up with a mismatch error still. Oh, there we go. Okay. Oh, was the error that we hadn't updated the training here the whole time? So what did we do? We have taken our single test case, we've extracted the values so that it's an array. We have reshaped it so that we've transposed it. And then from the training data, we've taken all of the values. We've calculated the cosine distance for each of them very quickly, I might add. And then from the training data, we found the row where the cosine distance is the smallest. So let's call this candidate. And then I'm just going to real quick do the reverse geocoding for the candidate and the reverse geocoding for our test case and see what we get and if they're like anywhere close. Because it's very possible that this is just not a good approach to this problem at all, and any time I spend fixing it is going to be not helpful. I'm also going to get rid of these because this was just for me figuring out things and it's not actually that important. Long term. Get rid of you. Peace out. You're good. All right. So this should be probably, I think, in a new cell because we don't want to have to redo the cosine distance every single time. Paste. There we go. Again, copy and pasting, just so hard. All right. Get rid of you. That works. I don't know why we ran that, but I sure did. That's right, because now it is of length 1, so we can just ignore that. We do not need to index into it. Oh, candidate, what is your whole deal? No axis named line for this time. Row column. Okay, yeah, it's wide. I'm okay with that. Can I just like so? Yeah, nice. Okay. And then like so? Nope. Like so? That might work. Let's give that a shot. Scroll back up. Oop. And let's get the values and see if this works. I don't know if it'll work with an array of dimension 1. Looks like it shan't. All right, let's get the first item. There you go. All right, Boulder, Colorado. That's our guess. And now we're going to do the exact same thing, but with our test case and see what we get. What have I done? Something's gone funky. These are slightly different data sets. Okay, so I'm suspicious about this maybe being in the training data. I'm suggesting to myself, I think that this may be leakage. I think we might have seen the answer previously. Just to catch back up on the chat, our shop said to not convert the train, it's also already multi-dimensional. Okay, thank you, helpful. Vivek RMK says, shouldn't one data frame be enough? We should get and choose 2 dist pairs, and we can group based on how close a pair is to each other in a single data frame. That sounds like it would work, but also I'm already committed to this approach. And I should say that the thing that we're doing here is me trying something just to see if it works, and I'm not necessarily committing to this as an approach because it has the problem of we need to figure out, we need to like have all of the data to find the most similar row in our app, and I don't want that. I don't want to expose this data because I don't have permission to. Faraday says, Academy says, hey, how come you don't allow raids? I don't know what raids are. That was on Twitch. Should I? Is it good? I don't know what a raid is. Sorry. That's why. Okay, so what do we want to do here? All I'm going to do is I'm going to change which one test shape is. So from the train, so let's do, we had like a bunch, let's try 100. And then I'm actually gonna get rid of this, and I'm gonna get rid of this, and I'm just gonna run these 3 cells, run. Nope, it still runs the same cell, doesn't hop down, and run. All right, so here we got Macomb, Georgia in Bibb County, and our actual one was Macomb, Georgia in Bibb County. Let's just try like another random one. Third time will absolutely, okay. Oh. Well, now that's interesting. That's real interesting. It's not leakage. We were just right. Huh. All right, and Indiana and Wisconsin are... Map of Listen, I only really know the West Coast and the South, and I own that. Let's just make pull up a little. Doo-ba-doo. Let's pull up a little map. All right, so Wisconsin there, and then we guessed Indiana, which is here, for Wisconsin, which is here. That's not too bad. Oh, this might work. Oh, that's frustrating. I'm upset that this is gonna work. Because for me, this is not a great approach, unfortunately, given the fact that you need to have the data set to apply this method, and I don't have a way to open source that. I guess I could. So what I was thinking is I guess I could do this serving the data somewhere else and then accessing it via API. The problem with that is that I'm going to have to do really strict rate limiting and authentication. Otherwise, someone can rebuild the data set basically just by querying the API a lot. And again, I don't have permission to share the data, and I want to preserve it. And that's also something that you might consider in like a commercial setting if you're looking up customers. You don't want people to like figure out your customer database. Surely no one would do that with user data. Surely. Let's do one more because this is fun. I have to say we had like 2,000, right? Let's just try the 2,000 one. I am a little upset that this is working so well. So New York and Ohio. Pull back our map, because I know not everyone's super familiar with New York and Ohio. Not super far off. And one more. Let's try, I don't know, 1,500. Rachel, this seems like a comprehensive way to test an algorithm. Shh. Don't give me that sass. Ohio and Pennsylvania, which are right next to each other. Also, this is the Harvard dialect survey, and Harvard is in Massachusetts. I'm like 80% certain, which is right there. So you're gonna have a little bit of a bias towards the northern East Coast. All right. It works okay. It does work okay. I think it would work better if we had more neighbors. So my question to myself, is there any way that we can do this without exposing the data? Faraday Academy says, it's when people send their viewers to your channel after they end their stream. I tried to raid you after my stream today. I'll try it again next time. Oh, okay. Yeah, I'll turn that on. You can tell I'm not very into Twitch. Oh, and Ryan also says, it's just someone else sending you viewers when they end a stream. Oh, cool. Yeah, I'll turn that on. So options here. Things I'm thinking about. Options going forward. This ain't gonna work. It's not gonna work as a classifier because we don't have a class, right, that we're looking for. We're looking for the most similar data in the data set. So I'm just gonna get rid of no. I'm just gonna add a note to this. This won't work right now. Right, so we're looking for a similarity score and not a class. We're looking for the most similar data. So options going forward. Option number 1 is add a class. And that could be like the admin 2 level. We could also kind of do what we're doing now. Vivek RMK says you can one-hot code the data so we won't know. So the problem with that is you would be able to reverse engineer it because you know you're going to be able to see how we take the raw text from the user and how we convert that into the same data frame as the data frame that we're comparing it to. So you would be able to figure out that, like, okay, this is where the user data, where they say what they call like a pill bug is, and that corresponds to this, you know, hashed row or whatever, and people would be able to reverse engineer which one's which would be a little bit of a problem. Enrique says exposing the data only with some kind of authentication. Yeah, like having a third server maybe that's more secure that you can tunnel into. The big problem with that is I want to open source this project. I want people to be able to you know, run this locally for like a linguistics class, or, you know, just for fun because I think it's cool. And anything that requires data that they're not going to be able to have access to is going to be a problem. And I could set up an API and let people who authenticate get into the API, but again, I have to do really strict rate limiting or else people are going to be able to reconstruct the data set, and I don't want that. So that's that problem. So I'm going to add that as an option because I think it is a good option. And if this were not like an educational open source project, I think that's what I'd do. And if this weren't an open source project period, if this is something that I was running on, you know, a secure server and people would just interact with it through the conversational AI, and I wasn't exposing all my code, then I don't think it would be a problem either. I think that would be a fine approach. However, that's not going to work for my particular application. And also, you know, there's places where you're really worried about security and data security and provenance, so you wouldn't want to expose your data either. So I don't think this is just an open source project problem. So continue to use finding most similar in the data set method, but so let's add a little pros and cons here. So benefit can train classifier. So what I think we've learned today is that nearest neighbors classifier can really work, because just doing sort of our simple one nearest neighbors or most similar cosine distance row, we got really good results. I think we ran 5 of them, and on the first 2 we were dead to rights. We got like the city correct, which is fantastic. Although we were also including latitude and longitude because I didn't remove them. So that also could just be leakage. So benefit to adding class is that we can train a classifier, which can be shared. The big drawback is that's going to be slow. Adding class reverse geocoding will be slow. So what I think I'm going to do is look into batch geocoding. So this is something that I know there are APIs for. It might be a little spendy. We'll see. We'll see if we have budget for it. So the benefit for the most similar benefit, simple and seems to work well. Cosine distance. Drawback. Need the data set to make the assistant work, and I can't share that. So I think the to-do there is look, well, think about hosting data securely. So those are my thoughts right now. Yeah. Enrique says, is there any way to anonymize users? So, I mean, it is fairly anonymized. Right now, you just have the answers to some of the questions and then the location of the user. And that's all the information that you have. But again, I just don't have permission to share the data, so I can't, I think even if I did other transforms, it would not, it just still wouldn't feel right, sharing the data in such a way that, you know, I think the people who very generously let me use the data in the first place would be happy with. So, going forward, just thinking about these things. I think the lightest, because the other thing is this is a fairly large data set, right? It's not enormous, but it's kind of big. It's 47,000 rows, and it's wide at this point too. It's what? Almost 200 columns, so that's not enormous, but I want my system to be fairly lightweight, because I'm going to have to handle the serving. That's not that big. Now what I could do, I don't think that'll work. So what I was thinking about is we could host this in a database, and do differential privacy. But the problem is, because we're going to be returning, we want to find the most similar rows. I don't think there's any way to ensure differential privacy, which is basically differential privacy is a way of saying, okay, if you run a query on a row in this data set, there's no way, you run a query on this data set, there's no way to determine whether or not someone was in the results of the query, someone's data was in the results of the query that was returned, for sure. Is a very basic description of differential privacy. Thinking about what's going to be most lightweight, I think biting the bullet and doing this enormous amount of reverse geocoding is actually going to be the best. I don't want to do it. So I think looking into batch reverse geocoding, we can price it real quick. Batch reverse geocoding. All right, here we see. Oh, okay, interesting. So it's just interesting. So there's a place where you can just upload latitude and longitude and get stuff back. Make sure your spreadsheet has headers. Consistently format the address. Not accepted mixed formats. If your spreadsheet includes addresses in Canada, include a country column. So this is for regular geocoding. I want to know about reverse geocoding. Interesting. Reverse geocoding. There we go. Coordinates, latitude, longitude. Huh. All right. And then what's the pricing on that? I just Googled this. I'm not endorsing or recommending this company necessarily. Oh, that's way cheaper than I thought it would be. Okay, so we've got what, 47,000, so it's gonna be, let's see, $9. That's not bad. I mean, I should say, for me right now where I am financially, that's not bad. There were parts in the past where that would have been undoable for me. 1,000 API calls per minute, so it's still gonna take a minute. It's still gonna definitely be slow, but definitely much slower than it would be, not slower than it would be on my computer. Maybe that's what I do. Yeah, let me check the time. It is, oh wow, we're over. Yeah, this is tricky. Like I mentioned, I think a couple of times before, but maybe not today. I am not really a GIS person. Like I've done some GIS projects, but it's not my bailiwick. I'm more of an NLPer. Yeah, I feel pretty good about county/parish/ incorporated city level of detail. Right? Because there are so the other thing I'm thinking about is there are some very small cities in the United States. Like there's cities with populations of 2, right? And it's very unlikely that they'll be represented in this data set, just based on sampling. I guess what I can also do is find a list of very small cities and remove anybody who's from one of those, just to, again, preserve anonymity. Because if I'm like, it's one of these 10 people from, I don't know, someplace, then it's fairly easy to Yeah. Yeah. So I think the thing that's going to make sense for me is to just go ahead and do this batch reverse geocoding, and then have an actual class, and then build a classifier, and then be able to use that to build a classifier, and then I can share the trained classifier, and I don't have to worry about the data. I think that's going to be my best option. Arshad says, why not open source only the latitude and longitude and let us contribute the reverse information? Great question. Again, I just don't have permission to share the data, and I think that includes like parts of the data, unfortunately. I'd love to. That would make my life easier if folks could just do this for me. But for this bit in particular, I am, alas, on my own. Yeah, so I think that's what I'm going to do. I know that the title of the last one was Reverse Geocoder, and the title of this one was K nearest neighbors. Technically, we did build a K nearest neighbors classifier where K is 1. So, I mean, we did not do what I said on the tin. Yeah, so I think what I'm going to do off screen is just go through and reverse geocode and get that for the data, and then figure out how to proceed from there. Yeah. All right. Thank you very much for joining today, everybody. I know it was a lot of sort of like talking through things and figuring stuff out, but what people have told me in the past is that they find that helpful. So I hope you enjoyed my struggle and found it informative. And thank you, everybody, for your suggestion and help, particularly with pandas, which continues to be vaguely frustrating. And we will be back tomorrow, actually. So I need to post on the YouTube channel about it. The paper reading group, the Rasa paper reading group, is gonna be, what's the word I'm looking for? Consistent, hopefully. So tomorrow, Maddie, who you may know from her fantastic talks and her works on the Rasa workshop, and I are going to be working on a paper about ethics in conversational AI, which is something that we talk about and think about a lot. And then on Friday, I'm going to be back with live coding again. And next week, no live coding for me. I'm on vacation, but there will be the paper reading group with Vincent and Maddie. So lots to look forward to. Hopefully y'all enjoy that. And if you come back tomorrow, I will see you then. And if not, I'll see you at some point in the future on the internet. All right. Thanks so much. And I will talk to y'all later. Bye.